Hello everyone, welcome to the channel. In our previous video, I have shown you how to perform a supervised image classification in how to load a Landsat 8 image into Earth Engine and set a visualization parameter and how to create a training data. So in this video, I will show you how to import our training data into our Earth Engine and how to extract the Landsat 8 bands and how to perform an accuracy assessment, and finally to download our supervised classification image to our Google Drive. So let's get started. So to create a training data, so in my previous video we have already created our training data. So that is water, build-up, vegetation and barren for our supervised classification model. So in this video we will import our training data and extract the Landsat 8 bands. So to import our training data into our supervised image classification model, we have to define a variable called labels equals to class. So you can able to remember for each of the samples we have mentioned the property as a class and the number and the value as 0. So here we are mentioned as class. So now created a variable called label equals to class. So now next we have defined a variable called bands. So now let us choose our required bands from our Landsat 8 image. So in order to choose the bands from our Landsat 8 image, we define a variable called bands equals to band 1, band 2, band 3, band 4, band 5 and band 7 from our Landsat 8 image. So we are selecting band 1, 2, 3, 4, 5 and 7 from our Landsat 8 image. So we are using the specific number of bands from our Landsat 8 image because we don't require to select all the 11 bands. So instead we require only the 6 bands to perform our supervised image classification. For that we defined a variable called bands and selected band 1, 2, 3, 4, 5 and 7. So now to extract this bands from our Landsat 8 image, we defined a variable called input equals to image. So here the image refers to our Landsat 8 image. So that is defined here, the variable image, that is Landsat 8. So we defined a variable called input equals to image dot select bands. So the band refers to this variable called this variable bands, that is band 1 to 5 and band 7. So in the next step we're going to import our training data into our supervised classification model. So to perform that, so you can able to see here, these are the different feature classes, that is our training classes. So for water we have around 54 elements, for build-up there is 78 elements, and for vegetation is 55 elements. So each of this element we have to merge together. So in order to perform our to import our training data into our supervised classification model. So to merge that, we defined a variable called training equals to vegetation. So here the vegetation refers to this specific variable vegetation, and similarly the barren here refers to this specific variable barren, and water body refers to this one. So the water here refers to this variable called waters, and the build-up here refers to this variable, this one, build-up feature class. So let us merge all these elements together. For barren we have to merge these 50 elements together, and for vegetation we have to merge this 55 elements, and for similarly build-up and water, for water we have to merge this 54 elements, and for build-up we have to merge this 78 elements to combine together this training data. So this specific function we are used to merge this training data together and import this training data into our model. So for that we defined a variable called training equals to vegetation dot merge barren, merge water, merge build-up. And to visualize this function, we have defined print training. So to visualize this result of this training data, we define print training. So now let us run this code. Go to this option called run script and click run script. So now we can able to see in the console section, so we have our result of this training data. So let us visualize it. So we have different features. We have total 237 elements. So when you add all these elements together, you get around 237 elements. So now let us open this. So let me check this out, feature. So go to the property section. So this indicates a class 2. So class 2 here indicates, so this is class 0, class 1, class 2 and class 3. So class 2 indicates the vegetation. So this indicates the vegetation. And let us view other classes. So this is also class 2. So this is class 0. The class 0 indicates water. So next we have to overlay our training points on the Landsat 8 image and to extract our Landsat 8 bands. So for that we defined a variable called train image equals to input dot sample region function and collection referring to training. So here the training refers to this training. So here where we have merged our training data together for vegetation, barren, water body and build-up. And properties we given label. So label here refers to this specific variable, that is refers to our class. And next scale refers to the spatial resolution of our Landsat 8 image. So that is a 30-meter resolution. So previously in the features, so we can able to see only the property section. We can able to see only the class. So in this way, in this section, we can able to view the bands. So now let us run this code. So let me close this. So go to the option called run script and click run script. So we are visualizing the result of our train image from this variable. So let us view this. So go to the properties, band orders. So now we can you can clearly able to view we have our bands here. So in the feature section, let me select this and go to the property. So now you can clearly able to visualize we have extracted the training data as well as our Landsat 8 bands. So band 1 to band 5 and band 7. So the next part of the step is we're going to perform some accuracy assessment. So before we're going to perform some supervised classification, we have to check for the accuracy of our data. So in order to perform our accuracy assessment for our data, we are using 80% of our training data for classification and 20% of our data for validation. So before performing our supervised classification, we need to assess our accuracy of our training data. So to assess the accuracy of training data, we defined a variable called training data equals to train image. So here the train image refers to this specific variable train image and dot random column. So it will generate a random column. And next we define a variable called train set. So train set refers to used for our so the train set will be specifically used, that is 80% of the data will be used for training data. That is a variable we define train set. So in this specific variable we have 80% of our data will be used for our training data in a variable called test set, where the 20% of our training data will be used for validation of the data. So for the training, we defined a variable called train set equals to training data. So refers to this variable training data dot filter less than random 0.8 refers to 80% of our data will be used for training. And for next variable, we define this variable test set equals to training data. So this refers to this specific variable. And dot filter greater than or equals to random 0.8. That is 20% of the data will be used for validation. So now let us perform our classification. So to perform classification, we defined a variable called classifier. So we defined a variable for classifier equals to classifier. We are called the Earth Engine classifier. So next we defined smile card. So smile card function is a regression tree model function, and it uses a regression tree model to classify our classes, that is our supervised classes. And dot train, we are referring to train set. So train set here refers to this particular data, that is our training data, that is our sample training data. And the label here refers to our class. So the label here that refers to So the label here that refers to our class. So here, so class we have this particular, that is water, build-up, vegetation, and barren. And last, bands. And bands here refers to this our Landsat 8 bands. So that is here. So this is our Landsat 8 bands. So the next step will be actually classifying our image. So what we're going to do is we're going to classify this Landsat 8 image into 4 classes. That is, we have let me show you that. So water, build-up, vegetation, and barren land. So we're going to classify our Landsat 8 image into 4 different classes based on our training samples. So now we're going to classify our Landsat 8 image into 4 different classes based on our training data. So for that, we defined a variable called classified equals to input. So here the input refers to our Landsat 8 image dot classify function. So we are referring our classifier. So we have defined our classifier here. That is our classification model. So this is our classification model. I'm just define classify function and referring to this variable. So this is a variable containing our classification model. So to view this details of this classified image, we have defined print classified dot get info function. So now let us visualize the result of this classified image. So go to the option called run script and click run script. So now let us view the details of our classified image. So we have bands and properties, system footprints, coordinates. So it is defined as classification. So these are the different 21 elements. Okay, so this property, and so in classification bands we have our classification and also property of this image, the coordinate, that is projection. And so now let us visualize the image of this classified image of our Landsat 8. So to visualize our classified Landsat 8 image, for our Landsat 8 image, we have defined a variable called land cover palettes. So to visualize our satellite image, that is to visualize the classified image of this Landsat 8. So for that we had to define a variable called land cover palettes. So for that we defined a color for each of this different so now let me change to water. So for water we define for this specific color, and for build up we define this color, and for vegetation this, and for barren we define this color. So now to add this layer into Earth Engine, and let us visualize our Landsat 8 image of classified 1. So for that we defined map.add layer classified. So the classified here refers to this specific variable, and palettes refers to our visualization parameter. So the palette here refers to our that is land cover palette, this variable. So for visualization purpose, with a minimum of 0 and to a maximum of 4, and output the layer as classification. So now let us run this code. Let us convert our Landsat 8 image into a classified image. So let us run this code. Go to the option called run script, click run script. So now let us visualize our result. So we have used 4 different training samples, that is water body, vegetation, barren, and urban area. So now let us view this. So we have our water body that is indicated in blue color. So that is clearly indicated here. So now let us view this. So here it indicates water body. So this is a lake. So that is indicated in blue color. And similarly, let us view this. What does this color refers to? So this color refers to vegetation. Now let us confirm it. So now let me go to the classification, turn this off. So it is the vegetation. So this specific color indicates vegetation, and red color indicates the urban area. So now let us view this. So this is all the urban areas. Now let us view the classification. So the classified also indicates it is of urban area, that is shown in the red color. So now let us view what is this. So we have our lakes. So in this study area has many lakes, and let us view what this color refers to. So that particular color refers to barren areas. So clearly indicated in this color. So the classified image clearly shows the water blue indicates water bodies, and this specific color green indicates there is a vegetation, and this light green indicates of barren areas, and red indicates the urban areas. So you can add more training samples. There is many classes. For this video, we just used only 4 different classes: water body, buildup, and vegetation and barren. You can add many other classes to this classification model. So you can add many features. So we have just used water buildup and vegetation and barren. You can also select many features in your study area. So we have converted that, we have transformed our Landsat 8 image into a land cover image. So you can also turn this training data off. Go to this geometry import, turn this off. So now we have converted our Landsat image into a classified image. So next we have to assess our accuracy of this classification. So now for that, let us perform that. Let us assess the accuracy of this classification. So next we have to test the accuracy of our classification. For that we have to perform an accuracy assessment. So to perform an accuracy assessment and classify our test set, previously we have defined there is variable called test set. The 20% of the variable will be used for the validation purposes. So for that, we're going to use the test set variable. So the test set variable will be used here and get the confusion matrix. So to assess the accuracy, we have to define variable called confusion matrix equals to confusion matrix test set refers to this variable. Dot classify the classifier. So here the classifier refers to our model, that is our classification model. Let me show you that. So this is our classifier variable. So next we have to create our error matrix. So here we have to provide 2 different parameters. That is our actual parameter, that is our classes, and our predicted one. So predicted here refers to our classified image. So actual will be our training data, and our predicted one will be our classification. So in order to assess the accuracy of our classified image, so basically this one will generate our confusion matrix. So now let us print our confusion matrix. So for that we're gonna use the print confusion matrix and mention as confusion matrix. So the variable confusion matrix. So here it refers to this one. So now let us run this code. Go to the option called run script and click run script. So now let us view in the console section. So now you can able to clearly view in the console section we have our confusion matrix. So that is for our 0 refers to our first training data, water, buildup, vegetation and barren. So 0 refers to water, buildup, vegetation and barren. So this is the confusion matrix. Now let us check the overall accuracy of our model. So let us check that. So to do that, we have to define print overall accuracy confusion matrix dot accuracy function. So now let us run this code again. So let us view on the console section. Yeah, we have our confusion matrix and our accuracy. So the accuracy states that the overall accuracy is around 83.63%. So it is around 83% accurate. So accuracy also can be measured using the specific function. So the overall accuracy of this model is there is 83%. So next we have to export our classified image of our Landsat 8. So to do that, let me show you that. So to download or export our classified land use land cover to our Google Drive, so for that we have to define export.image.to drive, and we have to give some parameters like image is of classified, description that is Landsat classified cart, that is if Landsat classified cart. So the cart here refers to classified and regression tree. So this specific technique that is called, that is cart classified and regression tree. So the scale is of 30-meter resolution, and region, that is a static region, is ROI, and the maximum we have to specify a maximum pixel, that is 1:10 power 13. So to download or to export our classified image to our Google Drive, all you have to do is go to the option called Run Script and click Run Script. So now we can view here. So we have our image, our classified image, as well as our Landsat 8 image. So go to the task section. So to export this classified Landsat 8 image to your Google Drive, all you have to do is click Run. So let me click that. So here the windows, that is a window popped up. So to export this, all you have to do is go to the option called click Run. So now you can able to view here. So the task has been submitted. It will take some time to upload your classified image to your drive. So you have to wait for some time. So in this video, I have shown you how to import your training data and how to perform a classification, and how to perform the accuracy assessment for the classified image, and last, how to download your classified image to your Google Drive. So how to export your classified image to your Google Drive. So thanks for watching, and please subscribe to our channel and give us a like. Again, thanks for watching.